I am able to transmit to your screen today. Let's see if my stream is working. Ooh, it says I am not online. It's not working. Let's run this again. Okay, it does say I'm streaming, so, oh, I see I have to press the play button. No. Oh, I see. Okay. Aha. Testing, 1, 2, 3. Okay. Okay, it seems that this is working, so if everybody can hear me, please confirm in the chat and we can start straight away. I'm going to wait just a quick moment because, I only literally just came online and I want to see, I want to make sure that everything is working fine. Please confirm in the chat that you can see my screen, that you can hear my voice, and that everything is working fine. I guess I'll just very quickly take another quick look at this, and it does seem to be working. Okay. So, hello everybody and welcome to another live stream by Timway Presents. Today is a special day because today, well actually not today but a few days ago, Cool Doom, who is already here in the chat with us, has published a new module called int sharp sharp, or int hash hash, but I have reason to believe it is pronounced int sharp sharp. And this is one of those modules that does not come with a manual because it challenges the community to figure out how it works by just running it or checking or seeing how it works, collecting data and doing logical deduction. Now, since I am a programmer and not much of a puzzler, I mean, I am a bit of a puzzler, but foremost I am a programmer, so I like to tackle these challenges by looking at the source code, or more precisely at the decompiled code, because obviously the source code, well, it's not obvious, but I don't think the source code is available before the manual challenge has concluded. So today on this live stream, I am going to try to decompile this module and see if I can understand from the code how it works, and potentially write a manual for it. Hello Ghost Salt, welcome to the stream. Alright, so first thing I'm going to do is I'm going to open the decompiler. Now you'll see that I've already added the assembly to it, but I've not actually looked at it yet, as you can see from the fact that it's not been expanded. And this one here appears to be the script for this module. So we're going to read through this code and see if we can figure out what it all does. Let me just very quickly check if there are any other classes that I don't recognize. Game effect player. I don't know if this is part of the module. I guess we'll find that out. Given that all of the examples are in this mod, which they really shouldn't be, Cool Doom, I'm gonna assume that that is also an example. So that means that the only thing here that pertains to the module is the module class itself. Also, maybe I should do this so that we can still see the chat and my notepad window. So, the first thing that happens when the module awakens is that obviously we get the module ID for the logging. There is a byte value here, which goes up to the number of buttons and gets incremented each time. So this is kind of like a for loop, but on bytes. And then here we have a onInteract handler. So whenever a button is pressed, this function handle press is called, and the respective button is passed in. Now, given that it is cast to integer here, which is obvious because it's an index into an array, it doesn't really make sense for this to be a byte, but okay. So, I believe that there are probably going to be 2 buttons because of this preview image here, which has 2 buttons. So I'm just going to assume it's 2 buttons. I'm also paying some attention to the chat. After all, that is why I put it in the corner. Are you using a plugin for deinspy that allows it to recognize KM selectables? No. What makes you think that it recognizes them? This is literally just normal C# code. There is nothing about this that is special. Alright, let's take a look at the handle press method, which obviously takes the button. And then we check the, so this is the index of the button. So I'm going to assume that the left button is going to be 0 and the right button is going to be 1. And if the module is already solved, then we don't do anything. That is completely normal. And I'm skipping over this here too, because that is normal boilerplate. It just add interaction punch does a little wiggle on the bottom when you press a button, which is what all modules do. And then there is this play game sound. The number 0 here is actually the value of an enum, which is button press. We've probably seen that before in other decompilations. Now here we have something interesting. There is a integer array called pointer. Okay, so let's see if that integer array, so that has 4 values, which presumably all start with zeros. Okay. Obviously there are others, but I'll look at them when I get to them. Okay, so if we press the button on the right, then the 4th entry, which is this one here, so I guess I'm going to call this Alpha Bravo Charlie Delta. So the first button is going to do most of the work, because everything else seems to be here in an else clause. So the right button is the only one that does something. The right button is the only one that does... Excuse me, what I meant is this is the only thing that the right button does. So button 0 we'll get to, and button 1 increment D. Okay, now we get a character from a list of characters. Let's see, the list of characters is this. So let's write that down. The characters are these. None of this is particularly obfuscated right now, but let's see what happens. So we look at what this character is. The character pointed at by delta. Right, so we look at the character pointed at by the 4th value in that pointer array. Alright, if it is a plus, and this dot started. Okay, let's see where started is ever assigned. I can't quite remember if it was already assigned. Okay, it is only assigned once, or rather it is only assigned in this one method, but apparently there are several places that do that. Okay, so started will start out as false. I think I'm going to do this for better readability. Whoops. Yeah, maybe I should save this somewhere. KTANE, let's just do this. KTANE manual challenge int sharp. I just saved that. I should have done that before I started the stream. Okay. So if this dot started, then we increment... Oh, I totally forgot about the plus 8 here, right? So increment d modulo 8. So this one here gets incremented modulo 3, which means that Charlie... You know what, I'm gonna write down the possible values here. This seems to be only between 0 and 7. This seems to be between 0 and 3. And this is only incremented if started is true. Okay. If this is a plus, then and if we started, then Charlie gets incremented. If it is a comma, which is the next one here, innards. Let's see, that is a 6 character, not character. Innards is 6 numbers. Yeah, let's see what that does. So 3, 4, and 5 are set to 0. So innards. I'm not quite sure how to succinctly notate this, but then it sets this one here to 0. So I'm gonna say that, and then Bravo, no, that's Charlie, is equal to 0, or is set to 0 rather. Right, so for the minus sign, which I guess I should really put next to the plus sign, this also only does something if started is true, and ooh, it seems that Charlie is incremented by 2, so I guess I'm going to do this. Oh, I see. Going plus 2 modulo 3, that is the same as decrementing. Okay. And then we have the dot, which also sets innards to 0, or at least those 3 parts of it, which is the second half of innards. And then pointer 2 once again becomes 0. So up to this point, that does the exact same thing as this, but it also sets started to false. So let's write that down. All right. Ooh, then there is a default and another switch. Why is that there? There is no extra code here, so I don't know why that's redundant. Okay. So the less than character, if started, would take Charlie, add 3, and then look at the innards. Oh, I see. So this looks at the second half of the array, of the innards array, and we go plus 9 modulo 10. Okay, so that suggests that the innards are values from, or at least the last 3 are values from 0 to 9, like this. And the less than thing here decrements the... Let's write it like this. So the element in the innards array that is at the position pointed at by Charlie is decremented. And I'm going to take a guess that the greater than sign, which is down here, yep, that does the same thing, just increment. Okay. So we've now found 4 things that only happen when started is true, but we still don't really know what the module is about, but hopefully we'll get to that at some point. Then we have this one here, which is an open curly. This sets started to true. And then this, let's see, we go through the... interesting. Okay, so this suggests that the first 3 values in innards have the quote-unquote solution, and the right half is basically what it needs to be. And if any of these are false, are wrong... Oh, wait, if any of these are wrong... Yeah, if any of these are wrong, then flag is false and you get a strike, and if all of them are true, then you get a pass. Right, and if you do get a strike, not only will it set the second half to true, but also this one. Oh, no, sorry, that's pointed to, that's Charlie once again. So that will also, so this basically checks the answer. I'm gonna call it that. So that seems to be what that means. Alright, so that is what the first button does. And then here we have text equals Okay, so there are 2 text objects, but the screenshot shows only 1. So at this point, I need to check what these are. I will need to run the game at some point to figure out. So I'm going to go back to this. I'm going to come back to this later. For now, I want to see what's in start, because I totally forgot that there is a start method. I only looked at awake. So there is more going on at the start. Whoops, I did not mean to click there. So store2 is a character array which is shuffled from stuff. Okay. Stuff is this. Okay, so we take this and then we shuffle that and set it. Okay, so store2 is a shuffled version of that. Right, let's reduce the font size there a little. I hope that you can still read it on the screen. Hello there, Banana Lord. Welcome to the stream. This code coming up is really gross. Don't scream at me. What? No, I think it's totally fine so far. This.store2 random.range. Okay. So this finds a random number between, for example, 10 and 20 or 20 and 30, etc. Okay, so store2. So we just assigned this. So okay, so the first 2 elements in store2 get overwritten, and the first one. No, wait, no. I see 2 of them, two random ones. Yeah, so one in the first 10 and one in the second 10. How many characters is this? Let me just quickly look at this. We can see that here that's 20 characters. Okay, so out of the first 10 and out of the second 10, one random element is set to either 1 or 2 in ASCII. Yeah, that makes sense. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that suggests that the number 10 is important here. So out of the first 10, one of them at random is changed to a 0, and one of these at random is changed to a 1. Okay. I hope that I will still be able to remember what this means, because this is quite condensed and cryptic. And then we said this dot store. Ah, okay. So initially we took a character array, and so this dot store literally just turns that into a string. So CoolDoom store2 therefore probably didn't need to be a field. It could have just been a local variable in the start method. As you can see, no other code uses it, so you could have just put var store2 here and use it only in this method. But that's just don't give me too many hints there. Okay, and then it sets this value into the third text thing, and then it runs an interpreter. Okay, so at this point I want to see, okay, so given that the screenshot here, okay, so now I get it. So the big screen here is going to be the third screen, or text of 2, and that one is going to have this code, but with the 0 placed somewhere here and the 1 placed somewhere here. Except, of course, that all of it is shuffled, which means that we don't know that these are the first 10. So there are going to be multiple zeros, but there's only going to be one 1. Oh, sorry, it's 1 plus... Right, okay, so you place a 1 here and a 2 here. Aha, and the entire string doesn't contain any 1s or 2s. So you can see... Okay, so this string is actually false. So your screenshot is a lie. It's probably something that you put in during development, and then you just screenshotted the development module. I tend to take a screenshot of the module in action during the game. Alright, and then we run something called interpreter. Now, it's counting to 20 because, yes, I don't know what you're talking about. This one here counts to 2. Okay. Oh, I see. You're talking about the screen. This is literally the numbers 1 to 20, but then modulo 10. That's probably what you meant. Okay. So, interpreter. So, given that it's called interpreter, and given that these characters here remind me very much of a certain programming language, a certain esoteric programming language, I'm going to assume that this is going to be an interpreter for an esoteric programming language, but the instructions appear to be the numbers 0, 1, 2, 3, etc. And then the result of that computation, I don't know yet. Oh, I see. No. Okay, I get it. Okay, so the digits are going to cause some calculation to be made, some computation, and then the expert is going to have to do the same calculations by hand, and then the expert will use these. I see what's going on. So the the right button will cycle between these characters because it's modulo 8 and there are 8 of these. And then the left button will execute whatever instruction is being shown on the button. And what these instructions do is they allow you to navigate these 3 values within the innards array, and then you can increment or decrement any of those, or set one to 0. In fact, this sets everything to 0, right? And then you do this to start the thing, and this to basically submit your answer. So I'm not entirely sure why the started is there, because it seems to me that all that does is it just causes these 4 instructions to do nothing. But I guess that's part of the rules of the module. So now let's see how these instructions work. So This is going to get a little more exciting than what we had so far, because now we get to figure out what each of these do. So, console.writeLine, I don't think you will see that in a module. This should probably say debug.log. But whatever. Alright, so this dot pointer, remind me what pointer was. Pointer has, okay. Okay, so far we've only ever used C and D. Okay. So this will use A. Okay, so the 0 instruction sets A to 1. The 1 instruction, num equals 0, which I guess it will be at the start, but this is a for loop. Okay, so this is a number that, okay, so the first time that we hit this instruction, that variable is gonna get set to 1, and Bravo is going to be set to the index of the number 2. Okay, so Bravo equals index of 2. I'm just gonna write it like that. But then the second time this number is hit, which is never, because the number 1 only occurs once. Like, remember here, like this digit string doesn't contain any 1s or 2s, except for the one that we inserted in a random place. So my guess is that this num variable is probably, yeah, there you go, it's used somewhere else. So this num variable actually kind of encodes some kind of automaton, so some kind of state. Okay, so I'm gonna say that, you know, if the state is equal to 0, then this happens, and then we go to state 1. Alright, now if the digit is a 2, then let's see. If we hit that first, or, oh wow. Okay. Right, time for a flowchart. Here we go. We are going to create a flowchart. So this num variable can have values from 0 to 5, apparently. Yeah, that's what it looks like. 5 is the highest number that I can see. So I'm going to create, let's see, a few circles here. Let's make them visible, not quite that thick, please. Maybe 1 pixel would be enough. Okay, so that would be right. Let's also put the number 0 inside, I guess. Not in that font. I want something. Something more like this here. Let's do that. Okay, so whoops. Let's align those according to the last selected. There you go. The 0 is now in the middle. And now we duplicate that. Whoops. Let's move that in increments of more like 10 pixels, please. There you go. And now this can be a 1. And then I'm going to assume... come on, let's use the keyboard. That's a bit more accurate. And then I'm going to assume that this is going to be number 2. Okay. You know what? I'm going to do the duplicating first, and then I'm going to put the numbers in afterwards. Like this, 0, 1, 2, and then this can be a 3, 4, and a 5. Okay. Now, we've already figured out, I'm going to put this here. Alright, I should probably do this so we can still see the chat. I want that here. So I'm going to put that here. Going back and forth between these. So, if the state is 0, then the number 1 is going to take us to state number 1. So I'm going to draw a little arrow here, like this. No fill, stroke paint that, make that 1 pixel, and give it an arrow. That's a bit much of an arrow. That's still a bit much. I think this should be enough. And then let's give that a label. So if we're in state 0 and we hit the number 1, right? So this time I'm going to use. Do I have Roboto? I don't have Roboto Mono, but I guess I can use Roboto. So if we hit the number 1, then we go to state 1, and we also set Bravo to the index of the number 2. Okay, I need to write that down somehow. So let's see, Bravo is equal to index of 2. Okay, let's make that reasonably small, but not too small, and then put that here. Okay. So if we hit a 1, then we do that, and we move over to state number 1. All right. So the next thing, yeah, I should probably save this in the same place that I saved this. So let's put that here. KTANE manual challenge int ##. Cool, Doom. 1 pixel isn't that small because this is just 100 by 100. Remember that it isn't really pixels, right? This is all scaled. That's what the S in SVG stands for. It's scalable vector graphics. All right, let's go back to the code, which is here. So if we encounter a 2, then we can go from state 4 to 5. So this line is going to look a bit wonky, but I'll just do it. There you go. And let's give it this. There you go. That's that. I probably should have used a different program for that, or I should have arranged them in a different way, but it doesn't matter for now. I will fix that later. So 4, oh my bad, 4 goes to 5, not 2 goes to 4. Aha. So 4 goes to 5, like that, I guess. And then this happens when we encounter the number 2. Save. Okay, if we are in 0 or 3, then we can get back to state 2. Ooh, okay. Let's do that. And let's also do, come on, let's just duplicate that. Wait, from 0 and 3 we go to 2, right? So it's more like this. And then I guess I can put that here and here. Okay, so that's that done. Now if we hit a 3, there is no state changes here. So you know what, so this is just state transitions. Now if we hit a 3, then alpha is going to be decremented, but modulo 3. I'm going to put that here, that alpha is 0 to 2. So I guess that's enough then. 4 means that innards of A is going to be incremented. And that one, right, I'm going to assume that all of these are 0 to 9. Right, so I guess I'll write it like this, even though that's kind of redundant, but you get the idea. Now if we hit a 5, then alpha is going to be incremented. If we hit a 6, then alpha is equal to 0. And if we hit a 7, then innards of alpha is decremented. I put a semicolon there out of pure habit. And then 8 sets alpha to 2. 9 innards, excuse me. Aha, so that increments all of the innards. Okay, so innards 0 plus plus, innards 1 plus plus, innards 2 plus plus. Okay. And then it says if num equals 5, then okay, so that's where this loop ends if you hit the number 5, which probably means that none of the rest of the string is going to get processed, which means that sometimes the 5 might end up at the start, or one of the 5s even, there are 2 of them, might end up at the start and you do very little of this work. But anyway, so after every instruction we get this, which is a B++, and then if B is greater or equal to, ooh, wait a second, are we actually looking at the character? Yeah, we're looking at character B, I see, I didn't even realize that. So that just means go to the next instruction. And if we're at the end, then, ooh, then we change the state. Okay, So the end of the string will take us from 1 to 3. So let's duplicate this, I guess. And we move from 1. Wait, it was from 1 to 3. So I should have done that. Alright, so let's move that to here so that we know that's what that means. And here I'm going to say EOF, which is end of file. Let's make that like size 4 or something. Okay, but if we're in state 2, then we move to state 4 on an EOF. So 2 to 4. Was it 2 to 4? I think it was 2 to 4. Yeah, it is 2 to 4. Okay. So then we put that there. Save that. And Bravo is, we do not go back to the start, we go back to where the number 1 was inserted into the first 10 instructions. Okay. So at EOF, we go back to where the instruction number 1 is. But we do not set the state. So when we meet the instruction 1, the state is not going to be 0 anymore, because the first time we hit it, we set it to 1, and then afterwards we never set it back to 0. Okay, so instruction 1 only does something the first time it is hit. Hello Goofy, welcome to the stream. What happened is that I've already decoded quite a bit of stuff here. It's a bit of a shame that you missed the start, but I'm probably going to edit this into a video and publish it on YouTube, so you can always see it there. So the logging now tells us what the answer is, and as I suspected, it is the first 3 items here that this is the result of the calculation or interpreting this program, and then the rest of the innards array is going to be what the user manipulates, and we have to set it to the right value. So now I'm going to run the game and see if I can use these rules that I've already discovered to run this module. Okay. So the first thing obviously is going to be to get the numbers from the top of the screen, from the screen at the top of the module. Hello Livio, welcome to the stream. Now in order to make sure that you guys can still see, the notepad and the chat, I'm going to change the graphics mode to something slightly smaller. Okay, I think I can do more than that. Yeah. Okay, so that fits. So let's apply that, and let's go to the mod selector and edit this profile where we disable everything except for int hash. There it is. And then we just run a bomb with just one int hash on it, standard rule seed, front face only, I guess, Zen mode. What else? Strikes doesn't matter in Zen mode. Widgets probably don't matter. Not just probably. We didn't see any edge work stuff in the code. So alright, so we have this code 36471873440508596429. There we go. And we start on the left. Do we start on the left? I think we start on the left. Pointer 0 is the one where we... Wait, which one was the instruction pointer? The instruction pointer is pointer 1. So let's see where this is assigned. So here we go to the 2. Here, we just increment it, which means that it's never initialized, which means that it starts at 0. So we start on the left. So we have a 3. Okay, I'm going to put my instruction set here. All right. And the current state is, of course, 0. So we meet a 3. And we do a minus minus. Now let me just very quickly make sure that the 3 didn't... Yeah, so all these instructions don't care about the state. So it's only 1 and 2 and 0. No, not even 0. Okay, so it's only 1 and 2 that care about the state. Okay, so A, B, and C were these, and they are values between 0 and 2. Wait, I'm talking nonsense. A is always 0, 1, or 2. Gosh, okay, so yeah, there we go, that's modulo 3. Okay, so I'm gonna put my variables A, B, C here, and we have, and D, I suppose. Well, do we even need D? I don't know. Oh, that's right, B is of course the arrow here, so we actually only need that and A, because, yeah, pointer 0 is used, but the other pointers are not being used. And in the case of inards, we only need the first 3. So I'm just gonna put 3 values here. Of course, they all start at 0. Alright, so with the 3, let's do this. Alpha minus minus. So alpha is now equal to 2. Next instruction is a 6. Alpha equals 0. Next instruction 4. Innards of alpha, which is 0, plus plus. These innards, they are 0 to 9. Okay. Next instruction is a 7, so we decrement that again. You know, it just occurred to me that alpha only ever points at the innard, so I guess I can do this and not even have to write this down. Alright, did I already do this? I lost track. Damn it, I lost track, so I have to do it all again, but now I know what's going on. So alpha is minus minus, 6 means alpha is 0, 4 means... yeah, sorry, no, I shouldn't have done that, I should have moved it, but it doesn't matter now because it went back to 0, and now 4 means we increment that, and then 7 means we decrement that, so we're back to 0, and now the 1 happens, so state is now 1, and the pointer moves to the index of the number 2, which is here. Okay, so here we have the 2. I said I was gonna get back to that. I'm gonna come back to that, but yeah, okay, so all this does is 4 goes to 5, 0 goes to 2, and 3 goes to 2, but we're currently in state 1, so none of these things happen. Next, 9, we increment all of them, doink, doink, doink. Okay, and now we reach the end of file, and I forgot to copy and paste this. Okay, so EOF means we just go back to 1. What else was there? Index 1, oh yeah, there's some state change. Alright, so I'm gonna write those down. 1 goes to 3, and 2 goes to 4. And we are indeed in state 1, so that becomes a 3. And now we go back to instruction number 1, which is here. Okay, then we have the 8, which sets alpha to 2, which means we go here. 7 means we decrement that. 3 means we decrement alpha, so we go here. You know, it just occurred to me that it's probably more intuitive to me to notate it like I still need to notate this somehow, and yeah, whatever. I'll keep going like this. So I just did this subtraction, which moved the arrow to here, and then we do a 4. We do that twice, so we increment this by 2. Then we have a 0, which puts the arrow here. Then we have a 5, which puts the arrow here, and then 0 puts it right back. 8, alpha equal to 2, means we put the arrow here. 5 means we put the arrow here. 9 means we increment everything. 2, 4, 1. 6 means arrow goes on the left. Then we increment that. Number 2. Okay, we're in state 3, so now that becomes state 2. 9 means, again, we increment everything. And now we're at the end of file again. So now we're in state 2, which means that becomes 4. And we go back to here. 8 means arrow goes here. 7 means we decrement that. 3 means we go here. 4 means we increment this twice. 0 means arrow goes here. 5, 0, 8. 8 goes here. And then we increment, so we go there. 9 means we increment all of them, so we get 5, 8, 2. 6 means we put the arrow here. 4 means we increment this. That's a 6. And now we hit the 2. We are in state 4, so state becomes 5. And then the 9 means we increment everything again. 7, 9, 3. And now we hit the end again. At which point does this end? It's when we're at state 5. Okay, so right now we're at state 5. So we end, and we need to enter 7, 9, 3. Now let's remind ourselves what the buttons do. Okay, so the button, I need to figure out which one of these is button 0, but I'm going to assume that it's the one on the left. So I can probably use the right button. Aha. Oh, I see. This is supposed to look like you're scrolling through the instructions, but the instruction on the left is the one that gets executed. Okay, so right now our buffer, I'm going to call it, is this. And we want to, and I'm guessing that we probably point at the first number at the start, and we want to increment that 7 times. So I'm going to find this character, which will increment it 7 times. 1. Interesting, I got a strike on... Oh, that's because this isn't... This is unreadable. Okay, this is the one that I want. Did the number change? No, it did not, so the answer probably also doesn't change. In fact, I could have just checked that here where handle strike happens. It does reset my input, and it puts the pointer, the arrow, back to the start. And oh, I need to start the damn thing. Oh, okay. So I need to, yeah, I need to press the this one here first. Good thing I remembered that. Okay, so this starts it, and now that it is started, I'm going to increment the first value 7 times. I suppose I could decrement it 3 times, but I'm just gonna do this now. That's 1, 2, 3, 4, 5, 6, 7. And now I need to move to the right, so I'm gonna find me a plus. And then we're gonna do this again. And we are now here. We want to do this 9 times. So this time I'm going to try that. So I claim that this is now at a 9. And now if I find the plus sign, I move that to here. And then once again, this time, oops, we want to increment it 3 times, so we use this 1, 2, 3 times, and then submit. And we did not get, okay, so I got that wrong then. Let's see, handle strike, handle pass. Okay, so, yeah, alright, let's see if the log file tells me anything, but I doubt it because I think I saw all of the log messages in the code. There's basically just that. The answer is 682. Ah, okay. So I probably did enter 793 as I intended, but it is possible that I did this instruction 1 time too many, and I should have gotten 682. And now that I had a strike, this is probably reset back to zeros, and the arrow is going to be here. So I'm going to try this all again. So let's do this 6 times. 1, 2, 3, 4, 5, 6. Next, and then we do this 2 times, right? And then find the plus, and then we do this 2 times, and then submit. Okay, so that was also false. Oh, it's because I didn't do the start thing. I need, okay, so when you get a strike, yeah, it said started back to false. Okay, alright, I should have remembered that. So it seems to me at this point that you never even need the other instructions. You really only need the greater than and the plus, really. But I suppose you can use the dot as a reset. So I guess I'll do that now, just to make absolutely sure that I know where I am. So now I need to do the start thing, this, and I can close the log file. I want to do 6 of these. 1, 2, 3, 4, 5, 6, plus, and then 1, 2, plus, and then two of these. And now I'm going to submit, and that is solved. So I totally forgot to turn on the audio, so you didn't hear any of that. You should have told me that before I solved it, because that was a very suitable soundtrack there. So I guess what this means, so there are two things that this means. First of all, this flowchart here, wait a second, did anything ever move out of stage 3? Yes, if you get a 2, there we go. So here we go from 0 to 1, from 1 to 3, from 3 to 2, and from 2 to 4, and then from 4 to 5, and that's the end. Which means we don't need this flowchart at all, because that's a linear progression. And the only oddity here is that if you hit the number 2, which in this case would have happened very late, so if you hit the number 2 before you hit the number 1, then you get a shortcut. That's all it is. So I could totally just renumber these. I could call this 0, 1, and then this one 2, this one 3. Yeah, in fact, that's it. You just flip the 2 and the 3, and then they're all in order. So if I do this now, if I just swap those two, then this would go here. Yep, and this would go here. This would go here. And this would go, that would just flip around. So that would go here. Right, and now you can easily see that it takes a linear progression through the states in the numbers 0, 1, 3, 2, 4, 5. Except that there is this one shortcut here. This EOF thing happens here. I'm not quite sure if that was supposed to be here. I've lost track, but it doesn't matter. I have it all in my notes here. We know that EOF does the state transitions. Let's put that here. There you go. All right. So EOF does these state transitions, and right. So 1 is the only thing that does something in addition to its stage transition. It also sets the instruction pointer to wherever the 2 is. 0 should go to 3. Thank you. You're probably right. Yes, the shortcut goes to here. Okay. I'm guessing that that was here. That was probably the one that went from here to the 4, so I'm just going to put that here. Okay, so I guess we can write the manual now. I'm debating internally whether I want to write the manual first or give my feedback on this as a manual challenge. So I guess I'll tease you with my feedback, and I'll tell you I will do the manual first and then give my feedback. So stick around for that. Here we are, giving you. I want to see, can we decompile Town of KTANE? Is that a module, Town of KTANE? Okay, I don't know what you were referring to. So I'm going to open just literally any random manual and save it as int ##. Replace all occurrences of the previous name with int ##. This thing here, this won't work, so we're going to change that to that. And let's also reduce the font size just slightly. And now let's remove everything here. Okay, I don't know if that's a suitable flavor text, but it's just something I just randomly thought of. So let's start. So first of all, let's do this. The string of numbers at the top of the module, in the screen, the string of numbers in the screen represents a series of instructions that compute a string of 3 digits 0 to 9. Execute those instructions to, well, what would be a good word for execute that implies that it's the human doing it rather than that's it. Trace the execution of those instructions to obtain the 3 digits computed, then use the instruction buttons to enter the result. Okay, so instructions. Okay, so let me actually open this manual here so we can see what it looks like. Alright, so instructions. I'm gonna make this in the form of a table. So we have 0. Okay, I need to clarify that the execution starts on the left. Trace the execution of those instructions starting at the far left to obtain, right, there you go. Okay, so this should probably be a TH, and then we have a TD. And I think I'm going to put that on a new line. So what does the 0 instruction actually do? Let's close that empty tab. I'm going to copy and paste this here. Okay. So first of all, during execution, there is a pointer pointing at one of the 3 values. Some instructions may manipulate that pointer, which initially points at the first. Okay, so what does the instruction 0 do? Move the pointer to the second digit. So 3 digits. Okay, so the 3 digits start out at 0 dot. Let's do this. There is also a pointer pointing at one of the digits, which initially points at the first. So this moves the pointer to the second digit. 1. Let's see. Oh, there is also this state. Yeah, since this is already pretty programmy, I think I am going to express this as state. There is also a state which is initially 0. It's also a state value which is initially 0. Okay, so 1. 1 second. I will be right back. And I am back. That did not take long at all. If the current state is 0, B. Wasn't B... Why does it say B here? Isn't that the same as... Oh, no, B is the instruction pointer. That's right. If the current state is 0, move to... jump. Jump is the correct term. Jump to the instruction 2 in the program. I'm going to... The string of numbers in the screen represents a program. A series of instructions that compute a string of 3 digits 0 to 9. Let's do it this. Like that. Trace the execution of the program, starting with the instruction on the far left to obtain the 3 digits computed, then use the instruction buttons to enter the result. The 3 digits start out at 0, right? If the current state is 0, jump to the instruction 2 in the program. The state becomes 1 / tr. Okay, then we have the digit 2. Okay, so we've done 0 and 1. So if the current state is... Right, so I am going to switch the 2 and the 3 to make this more reasonable. Wait a second. Yeah, that's right. Okay, so 0 becomes 3, 2 becomes 3, 1 becomes 2, 3 becomes 4. And that's it. Okay, if the current state is... okay. If the current state is any of the following, it changes as follows. And then we have... right, let's just write it in one line. 4 becomes 5, which I guess 0 becomes 3, 2 becomes 3, 4 becomes 5. Other values remain unchanged. Nothing else happens. Alright, I want to like do some more copy and pasting so I don't have to keep retyping the HTML code. Alright. Ultra detail low. I don't know what you mean by that. Well, execute instruction 2 is implicit in the fact that we jump to that instruction, so I'm gonna assume that the reader knows that. Now, A meant move the pointer. I'm going to underline this so that the so that it is clear that this is always a technical term, which you can look at the the text up here to see what it means. Move the pointer 1 digit left, wrapping around as necessary. Alright, so that's the 3. Now I'm gonna write the 5. Move the pointer 1 digit right. There we go, 3 and 5. And now let's do the 4, which says increment the current digit modulo 10. I think that's clear enough. And then obviously 6 is, no, 7 is decrement the current digit. This time it's not so clear because -1, yeah, okay, so in that case 9 becomes 0, 0 becomes 9. There you go. Now the 6 is move the pointer to the leftmost digit. And then 8 is move the pointer to the rightmost digit. And I'm going to call this the middle digit because there are only 3. And then 9 is increment all 3 digits, but of course 9 becomes 0 as before. So EOF, this is when you hit, when the when execution hits the end of the program. That was just a clarification. Let's make that 2 separate paragraphs. You know what? I'm going to do this. The current state changes as follows. 0 becomes other values, because I already say other values remain unchanged. So I guess I can literally just copy that, make that a p tag. There we go. The current state changes as follows. 1 becomes 2, 3 becomes 4. Other values remain unchanged. Then jump to the 1 instruction. There we go. So notably, the expert at this point doesn't even need to know that there is always going to be a 1 or a 2 instruction. They will just never run into a case where there isn't one. Okay, then input. Using the using the button on the right, switch between the various commands. Use the open curly command to start your input. Yeah, I was gonna put a warning like you have to do this before doing anything else. Right. Okay. Let's see. Let's see. So here we have them. Okay. Use the plus and minus instructions. Oh yeah. So during input there is a pointer. In this case, should I really call it a pointer? Okay, yeah, I will. Pointing at 3 input cells. Yeah, I'm gonna underline that as well. The cells start out at 0, and the pointer initially points to the leftmost digit. Points at the leftmost digit. You know, cell is, I'm just going to call them digits. During input, there is a pointer pointing at 3 input digits. The cells start out at, the digits start out at 0, and the pointer initially points at the leftmost digits. Using the button on the right, switch between the various commands. Use the button on the left to execute, I guess, the command shown on it. Use the open curly command to start your input. Use the plus and minus instructions to select, to move the pointer between digits. Okay, so again, I'm going to underline that, and then use the less than and greater than instructions to increment or decrement the current digit modulo 10. Now that we've explained in the previous year that 9 becomes 0 and 0 becomes 9, I'm going to assume that saying modulo 10 this time is enough. Use the close curly command to submit your input. Okay, you never need any of these instructions, but I'm gonna say the comma command can be used to set the digits back to 0, to set all 3 digits back to 0. Okay, the comma or dot command can be used. If the dot command is used, the open curly command must be used again to start input. If the submitted, right, I suppose we can do this. If the submitted answer is incorrect, the cells, the digits, the input digits are reverted to 0. The pointer, which again I'm going to underline, is moved back to the first digit, and the open curly command must be used again to begin input. Yeah, I guess that's it. Alright, let's take a look at what this looks like. That is obviously too much for one page. I think that's good. I think I'm just going to change that to 2 pages. So we're just going to end the first page here, and then start the second page here. Right, and then we just change this to page 1 of 2, page 2 of 2, and there we have it. Alright, let's see what this looks like when we turn that into a PDF. Alright, that fits perfectly on the page, that's good. And then the next thing we need to do is to create an SVG. I don't think I need this flowchart anymore. I really expected this flowchart to be more complicated. I literally just erased this by saving the file. Weird. Okay, so let's open the component SVG. Save it as int #hash.svg, I guess. And set ourselves a little grid with, let's make it 20, I suppose. Alright, let's draw ourselves a little, you know what, I'm going to use this screenshot as a template. Let's copy this, put that here, make it 0, 0, what's the size? The size is 348, there we go. And now let's move this a little bit so that it matches the frame. I think that's good enough. It doesn't have to be perfect. It doesn't have to be precise, rather. It does have to be perfect. Alright, so we're gonna have a screen there. Let's make this less visible. So we're gonna have a screen there, and that screen is going to have a valid program on it. So I'm going to use the one that I had here. And I do not want it in this font, but let's see what kinds of fonts I guess I could use. I suppose fixed sys would work. Let's make that font size a little bit bigger. I suppose, yeah, this actually looks very much like fixed sys, just squashed a bit. So I'm going to squash this as well to make it look similar. And there we go. So let's turn that into curves, and then let's align this to put it in the exact middle. And then we're gonna have a button here and a button here, and those obviously should not have opacity, so let's set them. That should probably be 100. Yeah, there you go. Okay, let's put a dot in fixed sys. At size, I don't know, 64. Even that is too small. 128. There you go. So let's put that. No, I don't want to center it. Okay, and then we copy that, put that here, turn that into a comma, and I guess I do want that moved up a little bit, but I still want it horizontally centered in the box. Alright, so we need to change that to a curve, we need to change that to a curve, and then we need to remove that. Okay, so that is a good SVG, and now we have a website here to minify this, so that this huge SVG file that Inkscape generates becomes this tiny little bit, and there is even more that I can remove using a regular expression, and then minify it again, and now it is much, much smaller. Look at that, it even fits on my screen. Alright, stroke line cap. I do not believe that I even need that. I also don't need that. So that's even smaller. Oh, look at that, there's another one here and here. That should do it. I just randomly noticed, what is the thickness of this? Well, actually, you know, why don't I look at it here? It says stroke width 0.86. Let me just very quickly see what that looks like. I think I might want to change that to a 1. None of them is affected by this, so I'm guessing that that is this is probably the writing in the middle, which doesn't have a stroke. So let's see what this one here. It says stroke width 2 up here, and there's another stroke width 2 here, which means that everything should now have stroke width 2. But it doesn't look like they do. Let's see, width Yeah, those are literally the only two. Oh, I see. This is on the path object. This is right. So the others will default to stroke width 1. So why don't we just do this? And now they all have stroke width 2. So now I've basically set a default value, and we can remove these. Okay, there we go. And that's our SVG done. Nice and small. So what else needs to be done? I think that's it. I can't think of anything else that I should do. So I'm going to generate the PDF and then send that to the author for inclusion in the module, I guess. Either that. Actually, Cool Doom, I probably should have asked you, do you already have a manual? Goofy, I see what you're saying, but I don't agree with you. There is one thing missing. Go ahead, please speak up. So I will cancel that and wait, 8 plus 1 equals 0. Well, so I guess I see what you're saying. If you read this absolutely like from left to right, then it would increment the current digit, and then if it is 9, it would then become 0. But I think the more intuitive way to read this, which is how everyone would read this, is increment the current digit except when it is 9, in which case it becomes 0. Wait a second, are you... Oh. Okay, are you saying that it isn't actually modulo 10? This is modulo 10. So, I don't understand what you're saying. So, okay, so your text, you're just complaining about the phrasing then, right? Okay. In that case, fine, then I will be absolutely super pedantic, even though I don't think it's necessary. But if the current digit is 9, it becomes 0. Otherwise, it is incremented. Are you happy with that? If the current digit is 0, it becomes 9. Otherwise, it is decremented. All digits are incremented except digits that were 9 become 0. Are you happy with that? And then I suppose here increment and decrement the current digit. Are you happy with it saying modulo 10 here, because this basically just harkens back to what was up here? Okay, you said yes, so I guess I'm gonna go with that. Okay, and it still fits into one line, so that's good, I guess. So let's do that. Let's print this, or not print this, but save it as a PDF. I'll put it into temp. There you go. And then send it to you. I will send it to you after the stream, obviously. If I don't, please remind me. State 5 breaks. Oh, I see. That is also still missing. That is correct. That is correct. The current state changes as follows. Other values remain unchanged. Then jump to the 1 instruction. If the state is 5, the program terminates. Okay. In that case, let's go back here. Generate the PDF again. And once again, if I forget to send you the PDF after the stream, please let me know. Please remind me. And with that, ladies and gentlemen, we've entirely solved this challenge. We have deduced what all of the instructions on the module do. We have correctly solved one module after 3 attempts. But that seems to suggest that I understand it correctly. And we have written a manual which explains exactly how it works and how to solve it. And with that, this manual challenge is now completely solved. And with that, I guess now it is time to launch into my feedback on this. And here goes. So, obviously this module is based on an esoteric programming language called Brainfuck, which is which consists of 8 instructions and a pointer. So you have a pointer that points at a cell, and you can either increment or decrement the cell. So it is very similar to what this is. But what this does instead is, of course, in actual BF, you don't have only 3 cells to change, but infinitely many, or an unbounded amount. Whereas here you have digits to encode the instructions, and they only manipulate 3 cells. Right, and these characters here, these are a little bit more reminiscent of the instructions that are used in actual BF, but except that the curlies, yeah, whatever. The point is, it's clearly inspired by BF. Now here's the thing about BF. BF is a full and complete programming language. It is a Turing complete, that is a technical term, which means that it can produce any computation. It can calculate, like, the digits of pi, it can calculate factorial, it can calculate literally anything that you could calculate with literally any other programming language. As a result, examining the behavior of a program based only on its output is close to impossible. Because what you would essentially have to do is you would essentially have to examine all possible programs in existence to see which ones produce similar output. So as a manual challenge, I would argue that this is very close to undoable and very close to impossible. The only way that this could be even remotely reasonable as a manual challenge is if you had a large set of programs that are very similar, and you could examine how the output between those programs differs. But with this particular design of an instruction set, that is still quite unreasonable, because even just one instruction in the middle of the program can change the result drastically, because all of the later instructions are affected by that instruction that was changed. So my feedback in general would be that a manual challenge should always be a module in which the input and output can vary more or less continuously. So if you vary just a small bit, then the output can be you can see how the output changes from changes in the input. That's one way of doing a manual challenge. Another way of doing a manual challenge is to have a module that consists of multiple individual pieces which can all be determined in isolation from each other. So it is not a single humongous puzzle, but rather a puzzle consisting of smaller sort of sub-puzzles. So good examples of the latter would be I'm going to mention my own manual challenges here. You might call this vain or whatever, but in the case of odd one out, my thought there was that it consists of individual sub-puzzles which may or may not occur in every stage of odd one out, and you can figure out each of those sub-puzzles in isolation of all of the others. They don't interplay with each other in complicated ways. And this means not only that you can figure them out in isolation, but also each of these sub-puzzles is relatively simple. And the name of the module already tells you what to do, right? You're supposed to find the odd one out. You only have to find the criterion by which, it is determined which one is the odd one out. That is, the fact that it is a set of multiple challenges, each of which is totally doable, makes it far, far more interesting and much less frustrating than a single sort of large set of rules that all interplay with each other, and the only way to figure out any part of it is to figure out all of it at once. Right, the other example I was going to mention is Password, which at the time of the manual challenge was called proper password, where you do have a complicated interplay between multiple things on the module, but you can look at each one of them in isolation, right? You can let me just quickly show you what Password looks like so you know what I'm talking about. So Password has these complicated looking symbols on it, like these, which initially might look daunting, but if you can collect several modules, all of which have, like, for example, the diamond shape, and then you look at the answers, then it is reasonable and it is doable to figure out what exactly those solution words have in common that could tell you what the diamond means. Alright, so that is not the case in int sharp sharp. In int sharp sharp, there is no indication on the module of how things relate to each other. There is no way to collect data and then notice some of the relationships. The only way to figure this out is to basically to already know how it works. So so that is my feedback. I think as a manual challenge, this is not really suitable. And I would recommend to any modder who wants to create another manual challenge for the community to think really hard and fast, long and hard, to think really long and hard about these kinds of things. Like, if you are the person solving a manual challenge, how would you go about it? Like, is there a way that you could deduce deduce anything without knowing anything about the module? So in the case of hard and fast, I misspoke. So in the case of int sharp sharp, I imagine that Cool Doom thought that you could find out about BF and notice that there is a programming language like that, and then theorize that some of the instructions are going to be similar. But with that already, you are vastly overestimating the rather, you are vastly underestimating the search space. You are underestimating the amount of possible guesses that a player could make that can be wrong, and that you cannot reasonably verify easily by playing with the module. Right. So by the way, this is another thing, right? There needs to be a way to easily verify a guess. So in the case of odd one out, if you have a theory as to what the LED red means, you should be able to just find a bunch of modules with a red LED and just verify whether your theory is correct. Right? With this module, you cannot verify any of the individual instructions without knowing all of the others. You can only verify all of it in one go. So that's impossible. Right, so as I said, if you're a modder and you want to create a manual challenge, definitely think about what the solver can do to make any kind of headway. Right, so in the case of this module, I almost forgot to mention this. I was going to say that even if you already thought of BF, the visuals of the module are explicitly misleading, because the things on the buttons look like instructions in BF, but the meat of the module is that the digits are instructions that execute a program, and the the quote-unquote BF instructions are only used to input your answer. So so if there is no way for the solver to figure that out, then there is no way for them to figure anything else out. So so that is basically my feedback, and I thank you all for watching, and I hope that you enjoyed the stream. I did enjoy decoding this with decompiling, and I totally invite people to create a manual challenge that can be decoded through decompiling. This is an entirely separate challenge that I do enjoy. So it doesn't have to be a sort of... So all of what I've just said, all of this feedback for manual challenge, applies to manual challenges in which you do not expect people to use a decompiler. Obviously, I was able to deduce the rules of this module by decompiling. So if anyone wants to create a manual challenge which is explicitly made to be decompiled as a challenge, then obviously the criteria for that are quite different. I think this particular challenge is reasonable as a decompiling challenge. I would even say that it is a bit easy, because as you noticed, I just went through the code, wrote everything down, and I might have overlooked like maybe one or two details, but on the whole, it was very easy to see what the code does. Right. So if you want to publish a manual challenge where decompiling the code is part of the challenge and is intentionally the desirable solve path, then I would be up for that. I would invite anyone to do that. In the case of password, or proper password as it was called, I did invite people to try and decompile the module, but that was not because I thought that it was a good decompilation challenge, but rather because the code was sufficiently complicated that I think it was not possible, and that people just wouldn't get anywhere through decompiling. So anyway, so I think I've talked enough now, and there was nothing going on my screen, so you were probably just bored. So thank you very much for watching, and I'll see you again next time when I live stream here at Timwe Presents.